Hello, this is another video that'll show you a formula that's based on the Pythagorean theorem, and that's the distance formula. Now let's suppose I have this point 4, 3 with the coordinates 4, 3, and I want to know how far this point is from the origin, or the distance from the origin to the point 4, 3. Well, if I drop down a perpendicular here and I trace along the x-axis here, what you'll notice is that I have a right triangle. And since this point has the x-coordinate of 4, I know that this distance from here to here is 4. And going up along the y-axis is actually 3. And if I want to know the distance from here to here, then what you should see is that this is actually the hypotenuse. In this case, I'm going to write it with the letter D for distance, the hypotenuse of the right triangle. And in our right triangle, the Pythagorean theorem, we know that x squared plus y squared equals the hypotenuse squared, or in this case distance squared. So x squared is 3 squared plus 4 squared is d squared, and this gives me 9 plus 16 equals d squared. So 25 equals d squared. Take the square root of both sides, and I get that 5 equals the distance, which is the hypotenuse of that right triangle. So that's one of the uses of the Pythagorean theorem, is to find distance on the coordinate plane. Let us suppose for a moment that I want to find the distance between, not a point from the origin, but the distance between 2 points. So let's say I have the point 3, 1 and the point 7, 4. Well, to find the distance, I want to know how far it is from here to here. But if I drop a perpendicular down here and connect it this way, then you see that I have a right triangle because it's a perpendicular. The distance here, if we count it, is 3. The difference here, if we count, is 4. And then again, I can have 3 squared plus 4 squared is the distance squared, or the distance right here, the hypotenuse of my triangle. And then again, I'll have 9 plus 16 equals d squared, and 25 equals the distance squared. Take square root of both sides, and 5 equals the distance, or the difference between them. So anytime, and that's the Pythagorean theorem, so anytime you're going to find the difference between 2 points, or the distance between 2 points, you're just going to use the Pythagorean theorem. To get this height here, how did we get that from here? We went from the 1 up to the 4. So this is the 4 minus 1. This is our change in y, our difference in the y values, and this right here is our difference in the x's. So if we wanted to come up with a formula, then we could say, let's say that this is x1, y1, and this is x2, y2. Then when we subtract the y's, we're going to get this difference right here. So this is, if we want to do the y's first, it doesn't matter. We can do the y2 minus y1. That's going to give us the a squared, and then we square it, plus x2 minus x1, and we square it. And then when we add it together, that gives us our distance squared, Pythagorean theorem. But that's not usually how we write the distance formula. We just take the square root of both. So on. When we do that, we end up with it all in one step. But it looks scary, it looks difficult. It's not difficult, but we don't even need to use the formula. We can just go back to what the formula represents. the change in the change in the y values, the change in the x values, or a squared or x squared plus y squared equals the distance squared. It's just the Pythagorean theorem. The Pythagorean theorem, written like that, looks a lot easier than our formula right here, but it means the same thing. So we can use the formula, memorize the formula, or just remember the Pythagorean theorem and realize that we subtracted the y's to get the height, and then we squared it, and then we subtracted the x's to get the change in the x value, and then we squared it, and then we took the add them together, and then we took the square root. But that's another theorem, or another formula that comes from the Pythagorean theorem. That's one of the usefulnesses of the Pythagorean theorem. I hope you found this interesting. Thank you.